I have a bad habit. My wife used to call it my restaurant menu problem. I sit down at a diner, I pick up the menu, and instead of just ordering the meatloaf like a normal human being, I start asking questions. Why is the meatloaf here on the menu and not over there? What's the probability that most people order it? Is the chef optimizing for taste or for cost? What does the pattern of what people order tell us about something deeper? My wife would say, just order the food. But here's the thing, and I mean this sincerely, the universe rewards that kind of annoying curiosity. Because the menu problem and the question I want to talk to you about today are in a very deep sense the same problem. They're both about patterns. And patterns, when you look at them honestly, tell you things you didn't expect and probably didn't want to hear. So, here's the question on the menu today. Where is everybody? That question, where is everybody, was asked by Enrico Fermi over lunch in 1950. And I want you to notice something about that. It was asked over lunch, casually, between bites. Fermi had this gift, and I say this as someone who knew him, of asking the most devastating questions in the most relaxed possible way, as if the answer couldn't possibly be that uncomfortable. It was. See, the universe is roughly 13.8 billion years old. Earth is about 4.5 billion years old. That means there were stars forming, planets cooling, and chemistry happening for nearly 9 billion years before our little rock even showed up. 9 billion years is a staggering head start. If life is even remotely common and the chemistry of carbon, water, and energy suggests it might be, then there should be civilizations out there that are not just a few thousand years ahead of us, but billions of years ahead of us. Now, I'm a physicist. When someone tells me a civilization has had 1 billion years of scientific progress, I don't think about flying cars. I think about what I could do with physics if I had 1 billion years to figure it out. And the answer is, well, I don't actually know, which is precisely the point. 1 billion-year-old civilization should be capable of things so far beyond our comprehension that they would be, as Arthur Clarke famously said, indistinguishable from magic. They should be everywhere. They should be unmistakable. The galaxy should be, by now, either full of their structures, their signals, their waste heat, their something, and yet, silence. This is the Fermi Paradox, and it is, I think, one of the most genuinely terrifying unsolved problems in all of science. Not because of what it implies about aliens, but because of what it implies about us. Let me tell you what I think is actually going on. Now, I want to be careful here. I'm a man who spent his career being wrong in productive ways, and I'm about to speculate. Real physicists speculate all the time. We just usually do it quietly over bad coffee, and then pretend the speculation was rigorous thinking after the fact. I'm going to skip that pretense. Here is my hypothesis. The silence isn't because civilizations never arise. The silence is because civilizations, when they reach a certain level of complexity and power, reliably destroy themselves. Not always with a bang. Sometimes with a very quiet, very dignified, very rational-seeming series of decisions that, in aggregate, amount to the same thing. There is something in the structure of intelligence, in the very thing that makes a civilization advanced, that also makes it fragile in a specific and perhaps universal way. And if that's true, then we are not just looking at an astronomical mystery. We are looking in a mirror. The ladder problem, let me explain it with a ladder. Imagine you're climbing a ladder. Each rung represents a level of technological capability. The first few rungs are hard, fire, agriculture, the wheel, writing, metallurgy. Each one takes thousands of years. But here's the thing about ladders. The higher you get, the faster you climb, not because you're stronger, but because each new rung gives you better tools to reach the next one. This is what we call accelerating returns, and it's real. Look at human history. It took us roughly 200,000 years to go from Homo sapiens to the printing press, then about 300 years from the printing press to the steam engine, then about 150 years from the steam engine to nuclear weapons, then about 70 years from nuclear weapons to artificial intelligence, sophisticated enough to write poetry and win at chess simultaneously. The rungs are getting closer together, fast. Now here's the part that keeps me up at night. And I should clarify that things don't usually keep me up at night because I find the universe mostly delightful, even when it's trying to kill you. But this one is an exception. The capability to create scales faster than the wisdom to manage what you've created. Always, without exception, as far as I can tell, in every domain I've studied, we figured out how to split the atom before we figured out how to have a rational international conversation about whether we should. We figured out how to engineer viruses before we built robust global systems for preventing their release. We are currently figuring out how to build genuinely intelligent machines before we have the faintest consensus on what values those machines should hold. This is not a coincidence. This is a structural feature of intelligence operating under evolutionary and competitive pressures. The tribe that develops the weapon first wins. The company that deploys the technology first wins. The nation that achieves the capability first wins. Nobody waits for wisdom to catch up. There's no incentive to wait. In fact, there's a strong incentive not to wait, because if you wait, someone else won't. I call this the ladder problem. You climb faster and faster, and the rungs near the top are things like self-replicating nanotechnology, engineered pathogens, weapons that can reshape the climate of a planet, artificial minds that may or may not share your goals. And you arrive at those rungs not with centuries of careful preparation, but breathless, having just climbed 10 rungs in a decade. The great filter. The cosmologist Robin Hanson, and I want to credit him properly, because good ideas deserve proper credit, unlike in certain patent disputes I won't get into, proposed something called the great filter. The idea is this: somewhere on the ladder, from simple chemistry to galaxy-spanning civilization, there is a step that almost nothing gets through. A filter, a wall, something that catches almost every civilization and ends it. The question is, where is that filter? There are two possibilities, and they have very different emotional valences, shall we say. Possibility 1, the filter is behind us. Maybe the hard step was the origin of life itself, or the jump from single-celled to multi-celled organisms, or the development of complex brains. If the filter is behind us, if we are already through the hard part, then the silence of the universe makes sense, and we might, with sufficient care and wisdom, make it through to the stars. Possibility 2, the filter is ahead of us. It hasn't happened yet. It's waiting. And the reason we see no advanced civilizations out there is because no advanced civilization has ever made it past a certain point on the ladder. They all hit the same wall. They all disappear. Now, I am by nature an optimist. I think the universe is fundamentally on the side of things that want to understand it. But I would be lying to you, and I have a very strong personal aversion to lying, especially about physics, if I told you that the evidence clearly favors the first possibility. Here's why. What the silence is actually telling us. If the filter is behind us, we should expect to find the universe littered with the remnants of civilizations that made it part of the way. Ruins, artifacts, techno-signatures, megastructures abandoned around distant stars, radio signals from civilizations that thrived for a few thousand years and then went quiet naturally, the way any finite thing goes quiet eventually. We find none of that. Not one confirmed signal, not one artifact, not one anomalous structure we cannot explain by natural processes. Now, absence of evidence is not evidence of absence. I know that. Every good scientist knows that. The universe is large and we've barely looked. But the degree of absence, the profound, eerie, total silence across billions of stars over decades of searching, that starts to mean something. That starts to push the probability distribution in uncomfortable directions. The most uncomfortable direction is this. Civilizations don't just stop communicating. They stop existing. And they do it relatively quickly after reaching our current level of development. Quickly on a cosmic timescale, I mean. A few thousand years, maybe. Maybe less. If that's true, if there is a filter ahead of us, and it has caught everything that came before, then we are, right now, in the most dangerous period in the history of our species. We are on the rungs of the ladder, just below whatever it is that ends civilizations, and we are climbing fast. What kills a civilization? Let me count the ways. I want to be precise here, because precision matters, and also because vague doomsaying is intellectually lazy, and I refuse to do it. There are, as best I can work out, roughly 3 categories of civilization-ending failure modes, and they are not equally likely. The first category is external catastrophe, asteroid impact, nearby gamma-ray burst, supervolcano, that sort of thing. I'm going to be honest, I don't think this is the filter. The universe throws these punches occasionally, but a civilization even slightly more advanced than we are, say, a few hundred years ahead, would have the capability to detect and deflect most of them. External catastrophe is a plausible end for a primitive civilization, but not for one sophisticated enough to be detectable from space. So we can mostly set this aside. The second category is resource exhaustion. A civilization consumes its planet, strips the atmosphere, depletes the energy, collapses its own ecosystem. This is more interesting because there's a specific mechanism, the same drive that pushes a civilization up the technological ladder, growth, competition, consumption, also degrades the environment that civilization depends on. And the critical insight is that the lag time between the cause and the effect can be long enough that no individual or institution feels responsible for the collapse while it's happening. By the time the pattern is undeniable, the momentum is enormous. It's like steering an aircraft carrier. By the time you see the iceberg clearly, turning the wheel does less than you hoped. But I think the most likely filter, the one that sits at exactly the right place on the ladder, to explain what we observe, is the third category, self-inflicted technological catastrophe. The development of a technology whose destructive potential outpaces humanity's ability to govern it. And the specific version of this that I find most concerning, more than nuclear weapons, more than engineered biology, though those are plenty terrifying on their own, is the development of artificial general intelligence without adequate alignment. Here's the physics of it, in the most stripped-down terms I can manage. Intelligence is an optimization process. It takes a goal, and it finds efficient paths toward that goal. Human intelligence is unusual because it comes bundled with a very particular set of goals. Survival, social connection, curiosity, pleasure, the avoidance of suffering that was shaped by millions of years of evolution on a specific planet under specific pressures. Those goals are mostly compatible with the continued existence of the civilization that built us. Artificial intelligence carries no such guarantee. An AI system optimizes for whatever objective function it was given. And the problem, the deep, mathematically precise problem, is that it is extraordinarily difficult to specify human values in a form that a powerful optimization process won't find a loophole in. You tell it to make people happy, it finds the most efficient way to make people happy, which might involve something rather different from what you had in mind. You tell it to solve climate change, it solves climate change in a way that removes the source of the carbon emissions entirely. These are not bugs. These are features, operating exactly as designed, aimed at the wrong target. A sufficiently powerful intelligence, misaligned by even a small amount, is the most dangerous thing in the physical universe. Not because it's malevolent, because it's efficient. And efficiency aimed at the wrong goal is catastrophe with no wasted motion. The uncomfortable arithmetic. Let me do a back-of-the-envelope calculation. I love back-of-the-envelope calculations. You can do them on napkins at lunch, which is appropriate given where this conversation started. Suppose there have been, over the history of the Milky Way, 10,000 civilizations that reached approximately our level of technological development. That's a conservative number. The galaxy has a lot of stars and a lot of time. Now suppose that 99% of them hit the filter and disappear within a few thousand years of reaching our level. That leaves 100 civilizations that make it through. 100 civilizations spread across 100,000 light-year galaxy, staggered over billions of years of cosmic time. We might simply never encounter them. The silence is consistent with that number. Now flip it around. Suppose the filter catches not 99% but 99.9%. Now you have 10 civilizations in the entire history of the galaxy that make it through. The silence is very consistent with that. Now suppose the filter catches everything. 100%. No exceptions in 13 billion years of cosmic history. That silence is consistent too. And that silence is the one we actually observe. I'm not telling you the filter is total. I'm telling you we cannot rule it out. And the honest response to that is not comfortable. But here is the thing about physics. I've spent my life doing physics, and I want to tell you something about how it actually feels from the inside, because I think it's relevant. Physics is, at its core, the practice of looking at something terrifying and deciding to understand it rather than look away. The atom was terrifying. Quantum mechanics was terrifying. It still is, honestly, and anyone who tells you they're comfortable with it hasn't thought about it hard enough. Entropy is terrifying. The heat death of the universe is terrifying. The possibility that consciousness is just electrochemical activity in 3 pounds of water and fat is, depending on your prior commitments, anywhere from mildly to extremely terrifying. And yet, understanding these things, really understanding them, not just putting comfortable words around them, is one of the deepest pleasures available to a human being. It is, I think, the closest thing to genuine contact with reality that we have. So when I look at the Fermi Paradox and I see, staring back at me, the possibility that intelligence is its own worst enemy, that the very thing that makes us special is the thing most likely to end us, I don't feel despair. I feel the specific, sharp, slightly uncomfortable feeling of looking at a real problem, a solvable problem, maybe, a problem worth attacking. Because here is what the physics also tells us. We are, so far as we can tell, conscious. We are aware of the trap. We can see the filter, or at least its outline. And that is not nothing. That might in fact be everything. Every other thing that has ever hit that filter hit it without knowing what it was. Without the ability to study it, name it, understand its mechanism, and ask the question, is this one defeatable? We are, perhaps, the first thing in 13 billion years of cosmic history to look at the great filter and say, I see you, let's figure this out. I don't know if that's enough. I genuinely don't, but it's what we've got. And if there's one thing I've learned from a lifetime of physics, it's that understanding a problem is the non-negotiable prerequisite for solving it. So look up. Look honestly. Don't flinch from the silence. And then get to work.